Okay, we want to combine these and we want to pick the right answer that's on your screen. Okay, that's on your screen. Here we go. Well, we're going to look for like terms, and I'm going to look at 8x squared. Why did I jump to this one? I didn't have to. I could have started there, but sometimes we like to start with the highest exponent. It's not a big deal if you don't, so don't go crazy if you don't. Okay, but I'm going to start here. Negative 8x squared has no friends, so negative 8x squared. But now I'm going to look at this other term, 3x. 3x has a friend. It's right there. So we have 3x minus 8x. So I have 3x, but I owe you 8x, so I owe you 5x. So if you look on your screen, that is choice B. That is choice B. However, it asks me to prove this when x is 4. So here's what that means. This means if I take 3x minus 8x squared minus 8x, and I take the answer, negative 8x squared minus 5x, and I plug in x equals 4, I should get the exact same answer. Otherwise, and if I don't, I made a mistake. So I'm going to do that. So let's take a look at plugging this in. Wherever I see an x, I want a parentheses. Remember, exponents on the outside. I'm going to move this over just a bit because I'm squishing. Squishing is never good. First rule of thumb. Okay, so here's my x is 4. And I get 3 times 4 is, well, let's use sort of operations. Don't go crazy. All right. Parentheses, don't have any exponents. There's your exponent. So I'm going to go do that. This is 4 squared, which is 16. Okay. Now, we have only multiplication, so we're going to go left to right. So this is 12. Okay. Multiplication, 12 minus 8. Negative 8 times 16 is a negative because a negative times a positive is a negative. 8 times 16 is 128. And a negative times a positive is again a negative. That's 32. So I have 12, but I owe you 128. If I have 12, but I owe you all of that, then I obviously owe you a whole ton. So I have to subtract those numbers. So 128 minus 12 is 116 minus 32. Well, I owe you 116, but I owe you 32, so I owe you 148. So that's negative 148. Now, if I did this right, I could plug in x equals 4 into my answer and get the exact same number. So let's hope I did this right. So I'm going to go here. That's my answer. I'm going to plug in 4, because if it works here, it's got to work there, if that's my answer. Order of operations says I have to do parentheses first, but I have no parentheses, but I do have exponents. So I'm going to do that first. Negative 8 times 16 minus 5 times 4. Okay, now order of operations tells me I have to multiply left to right. So negative 8 times 16, I'm cheating, it's right there. Negative 8 times 16 is negative 128. A negative times a positive is a negative. 5 times 4 is 20. I owe you 128. I owe you 20. So I owe you 148. I keep doing this, and I know you find this irritating probably, but I keep doing this to show you how algebra connects to arithmetic. This is just not arbitrary stuff. X squared, it all stands for a number, okay? And instead of saying this is true for this one problem like we can do in math, we can say this is true for all real numbers in algebra. It's kind of really cool. Okay, so B was my answer, and all I had to do was combine like terms. And again, to combine like terms mean we need the same variable factor, and we keep the like term and just combine the coefficients. Okay. Well, what we've been doing is very simple expressions. Maybe we want to really kind of do some different kinds of expressions in a minute. So take a look at the next question that's in your workbook. And it says, how many terms are in each expression? So let's take a look at that. Okay, I'm going to actually write this down just so you can kind of follow what I'm doing here. So number 1, again, we got to get all the smudges off the board so there's no negative problems. Okay, says negative 5x squared y. Number 2 says 4x cubed minus 3x squared minus 5x plus 1. Sorry, that was just a good one. Number 3, I like the long ones. X to the 5th minus 1. Okay, here's the deal. I look at this, and I see these are all attached by multiplication. There's no plus or minus in here, so this is one term. I look here, every time I see a plus or a minus, I have a new term. So this is one term. See a minus, new term, plus, new term. So there are 4 terms here. Same thing here. I look, count the terms, I look for a plus or minus. 1 term, 2 terms. So there are 2 terms here. Now you should know the names of these expressions. We're going to start with all of these are polynomials. All right, you know what a polynomial is? I'll tell you, hold on. Oh, that's not how you spell polynomial. Look, but I goofed, and I goofed not really on purpose, but accidentally on purpose, because I was thinking about the joke I was going to tell you. Okay, watch. Polynomial? Well, don't watch. Okay, you can watch. I'm going to cover it up anyway. Polynomial is a skinny bird. Polynomial. They didn't eat. Okay, good. All right, anyway, let's get back to this. Each of these are polynomials, and what poly means many, okay, and it's a polynomial because a polynomial is a finite sum. That means a countable number of terms, okay? So all of these are polynomials. But when you have 1 term, it's called a monomial. When you have 2 terms, it's called a binomial. 3 terms is a trinomial, which makes sense, bi meaning 2, tri meaning 3. 4 terms are generally just called polynomials, or some people call them multinomials, but I would just call this a polynomial. Okay. Well, why am I telling you about these names? Because now we're going to figure out how to add and how to subtract them, and it's really, really simple. You can do it 2 ways. You can do it horizontally, and you can do it vertically. I don't like to do them vertically, and there's a reason for that. So I'm going to do all my addition and subtraction horizontally. You might say, well, vertically is sometimes easier. It is easier in addition, but it is so not easier in subtraction. So I just do them all the same way. Okay, and if you've been following us so far, you won't have a problem doing it horizontally. So let's look at this. It says, add 6x to the third minus 4x squared plus 3 and negative 7x squared plus 5. Okay. This tells me that this is one polynomial, happens to be a trinomial. This is another polynomial, happens to be a binomial. Who cares? And we want to add them. What we're going to do anytime we want to add or subtract polynomials is we're going to use parentheses. We're going to put the entire polynomial, each one, in a separate parenthesis. So it's going to look like this. Okay? 6x cubed minus 4x squared plus 3. It says to add. That means the and tells me where the plus goes. Negative 7x squared plus 5. Now, we are not going to add or subtract until the parentheses are removed. Okay, and the steps are in your workbook and on the screen as well. We're not going to add or subtract unless we get rid of these parentheses. That's incredibly important. So first I want to talk to you a little bit about this. There's actually a 1 here you don't see. Same thing here. I cannot combine what's inside because they're not like terms. Here either. I cannot combine what's inside. They're not like terms. I have to look for that. But if that's a positive 1, I would have to distribute that 1. That will not change what's in here at all. Same thing for this. These are called non-essential parentheses. So yes, I did start like that, but in the end, I really just have this. Watch. 6x cubed minus 4x squared plus 3, because think about distributing a 1. 1 times anything is the anything. Okay, now a positive times a negative is a negative 7x squared plus 5. Now I know what you're thinking. You're thinking, why did she put those stupid parentheses in? Why didn't she just leave them out? Here's why. Because later in subtraction, it's going to make a huge difference. It doesn't hurt to do a little extra, but it does hurt not to do enough. So I put them in on purpose. Here's what I'm going to do. I'm going to go looking for the highest exponent, and that's this one. You don't have to do this, but I'm going to do it. Look for the highest exponent, that's this one. I'm going to start there. Numbers last, plain numbers last, which we call the constant. 6x to the third, or 6x cubed, no friends. So he just comes along for the ride. Okay? Now, the next x, or with an exponent of any kind, is this one. Negative 4x squared. Here's his friend. They are like terms, same variable factor. So this is, if you can't see it, you can move it over. I don't want to move them there. There is a reason for that. So it's I owe you 4, I owe you 7, I owe you 11x squared. So this is minus 11x squared. And then finally, we just deal with the numbers. The numbers are, did I lose my little marker? It's okay. Okay, positive 3 and positive 5. So I have 3, I have 5, so I have 8. So that's my final answer. I cannot do anything with that because they're not like terms. So that's my answer. 6x cubed minus 11x squared plus 8. Let's take a look at this problem, and then you'll see why I like to do these horizontally. Okay, subtract 5y squared minus 3y plus 2 from 2y squared minus 2y minus 9. Okay, here's the big key word, right? Whatever comes after the word from has to go first, so we're going to use this first. I'm going to put it in parentheses, and we're going to go 2y squared minus 2y minus 9 minus 5y squared minus 3y plus 2. So from changes the order. Now take a look at this. This is what I just said before, that we want to keep these polynomials in parentheses. Now think about this. There's a 1 here, but this one is a negative 1. So that's going to change everything in that parentheses. This one is non-essential, this one, because when I distribute it, because I can't combine what's inside, they're not like terms. When I distribute this one, nothing's going to happen. But I need to take off my parentheses before I try to do any of these problems. You should never be trying to combine unless your parentheses are gone. I distribute this negative 1, and if you remember from before, what that'll do, it'll just change all the signs. That's all it will do. A negative times this positive is a negative 5y squared. A negative times this negative is a positive 3y. A negative times this positive is just a negative 2. So all it did was positive became negative, negative became positive. That's all it does. It changes all the signs. Now we're going to look for some like terms, some friends. 2y squared is the highest exponent. It has some friends here, negative 5y squared. So if I have 2, but I owe you 5, I owe you 3y squared. I'm going to get rid of that. I'm going to come here, negative 2y, positive 3y. I owe you 2, and if you need to do the work, do it to the side. I owe you 2y, I have 3y, so I have a y. And then finally, the numbers. I owe you 9, I owe you 2, I owe you 11. And that's it. Negative 3y squared plus y minus 11. You can do this, I'm not even going to show you, but you can do this vertically up and down. But then you have a problem with the signs changing. The reason we saw the signs change in subtraction is because we saw this distributing. So subtraction makes those signs change because we have to subtract the whole thing. I'm subtracting this whole thing from this, so all the signs change. You won't see that vertically. You'd have to just change the signs because you know you're supposed to. Okay? So I'm not even going to show it to you, but it can be done. So that wraps up adding and subtracting polynomials. The next thing we'll be doing is solving multi-step equations.